In our paper, we summarize the past to predict the future, using natural language descriptions of context to boost multimodal object interaction anticipation in egocentric videos. Let us familiarize ourselves with the task of short-term object interaction anticipation. Given a sequence of observed video frames, the task requires anticipating the location of the next interaction, the verb label, the noun label, and the time left to contact, or TTC for short. In this example, the object location is represented by the red bounding box, the verb label is take, the noun label is food, and the time left to contact are 1.37 seconds. As you can see, the user does indeed take the food. This is a challenging task because the visual scenes are usually cluttered as seen in this example, and human behavior is inherently complex and ambiguous. Solving this problem is essential in building intelligent agents that can understand human behavior and provide assistance, be it to accelerate personnel training or prevent dangerous actions. A model suitable for this task requires a detailed understanding of both the past and the current visual cues. We propose to use language descriptions to summarize past actions and salient objects. More specifically, we propose transfusion, a multimodal fusion model for object interaction anticipation that combines action context descriptions and images. This provides the required temporospatial action context for the prediction task. We first use off-the-shelf vision language models to extract action descriptions from past frames, together with a list of task-relevant objects. We then aggregate the result over multiple frames to obtain more stable language descriptions. The summarized language context is subsequently forwarded to the transfusion model, together with the prediction frame, to obtain the outputs. We use a convolutional visual encoder and a large language model to process the input prediction frame and language context. Transformer encoder layers then fuse the obtained visual and language tokens in parallel at multiple feature scales. Afterwards, the fused visual tokens are gathered into the original feature map shape before being fed to the faster RCNN classification and regression heads. We benchmark transfusion against the current state-of-the-art works on both versions of the Ego4D short-term object interaction anticipation dataset on multiple metrics: noun MAP, noun verb MAP, noun TTC MAP, and an overall noun verb TTC MAP metric. Let us look at transfusion's performance on the first version of the dataset. We outperform all state-of-the-art methods for 3 out of 4 metrics on the dataset's test set and approach the state-of-the-art performance for the remaining metric. The same holds true for the second version of the dataset. This validates the advantages of our action context modeling strategy for the interaction anticipation task. Comparing to the official Ego4D baseline, we observe consistent gains in classification performance, 15% and 22% improvement respectively for the top and tail noun classes, and more than double the performance for the top and tail verb classes. Here, we present a qualitative comparison of our method against the Ego4D baseline. The green bounding box denotes the future interaction location, and on top of the image, we have the ground truth action label, in this case, open drawer, in 0.1 seconds. We see on the right that the Ego4D baseline fails to detect the correct bounding box and action labels, while our method, shown on the left, manages to get both right with a reasonable TTC prediction error. We compare our language-aided method against an alternative version of our architecture that makes use of video features instead. The language-aided method outperforms the video baseline, showing the suitability of language to compactly summarize large time spans of activity. In conclusion, we introduce the concept of action context and present a novel method for predicting future object interactions that uses a single prediction frame and natural language summaries of past actions as well as the surrounding environment. Experiments on the Ego4D short-term object interaction anticipation dataset show the effectiveness of our multimodal fusion model. They also highlight the benefits of using language-based context summaries in a task where vision may appear to suffice. Please check our paper and supplementary material for more experiment results, ablations, and qualitative evaluations. Thank you for watching.